This is Homeschool 101, a collaboration between ABS Television and the Ministry of Education. Stay attentive and attempt all activities. And now, today's lesson.
Welcome to our final episode of Mathematics Homeschool 101. Today, we're going to take a look at geometry, specifically transformational geometry. As usual, before we begin our lesson, let's go over the practice problems from the previous lesson, which was on algebra. So our first question says, if 3x over 2 plus 5 is equal to 17, then x is equal to what? Let's reread the question again. If 3x over 2 plus 5 is equal to 17, then x is equal to what? So here we need to solve for x, which means we're going to get rid of everything else that's attached to the x by taking them across the equal sign. Okay, so let's just rewrite the problem. We have 3x over 2 plus 5, and that's equal to 17. And so the first thing we're going to move is our plus 5. So on our left, we have 3x over 2, and that's equal to 17. And remember, when you take things across the equal sign, the sign changes. And so because the 5 was added, now it's going to be subtracted. So 3x over 2 is equal to 17 minus 5, and that gives us 12. And now the next thing to get rid of is our 2, because our 3x is divided by 2. And so the opposite of division is multiplication. So we're going to multiply by 2. But you have to remember that what you do to one side of the equation, you must also do to the other side of the equation. So those two cancel. And on the left, we're left with 3x, and that's equal to 12 times 2, which is 24. And then now, in order to find x, we're just going to do the opposite of what's happening, which x is being multiplied to 3, and so opposite of multiplication is division. And so I'm going to divide by 3 and divide by 3. Therefore, x is equal to, 3 goes into 24, 8 times. Okay, so our answer there is B, 8. Question 2. The value of negative 3n times negative 5n is what? So take a look at our options, but we also know how to multiply. Remember, when you multiply, that there are certain things that are going to happen. We have to add powers, and negative times negative gives us a positive. 3 times 5 is 15, and n times n gives us n squared. So negative times negative is positive, and so our answer there is 15n squared. Okay? Question 3. If m star n is equal to the square root of mn minus n squared, then 5 star 3 is equal to what? Just repeat the question. If m star n is equal to the square root of mn minus n squared, then 5 star 3 is equal to what? So remember, this is what we call a binary operation. And so wherever we see m, m becomes 5, and wherever we see n, n becomes 3. All right? So using the square root, we're just going to substitute. So we're going to have the square root. M is 5 times n is 3 minus n squared. N is 3, and so it's 3 squared. Okay, so 5 times 3 is 15 minus 3 squared. Remember, when you square something, the base is multiplied by how many ever times the power is. So in this case, it's squared. So 3 times 3 is 9. Right? So we're left with the square root of 15 minus 9. And 15 minus 9 is 6. Now, we're going to just stop there at the square root of 6, because 6 is not a square number. And if we look at our options, the answer is actually right there in A. So A, the square root of 6. Question 4. If A is equal to 5, B is equal to negative 2, and C is equal to 3, then 4AB plus 6C is equal to what? So A is 5, B is negative 2, and C is 3. So wherever we see these letters, we just substitute the value in there and follow whatever the operation is, okay? So, substituting. Let's just rewrite the problem. 4AB plus 6C. A is 5, so 4 times 5. B is negative 2 plus 6C. C is 3. So 4 times 5, that's 20, and 20 times negative 2. So if we just double the 20, that's 40, and because that was a negative, positive times negative is negative, so we get negative 40 plus 6 times 3, 18. And here we have negative 40 plus 18, all right? So when we look at this, we know that our 40 is greater than the 18 in terms of the number itself, but the 40 is negative, and so we can already say that our answer is going to be negative. So in this case, we can eliminate C and D, and we also know that when we're dealing with negative numbers, that because these signs are different, we're going to subtract. So if I take 18 from 40, I'm going to get a negative 22. Right? So our answer is A.
You're watching Homeschool 101.
So our focus for this final episode is the concepts behind the designing numerous things in our home. So you may see it in the design in your couch, curtains, tablecloth, sheet set, wall hanging, clothes, you name it, even a tie, all right? So transformations, when we talk about transformations, transformations involve taking an image and altering its position, orientation, or size to produce another image, okay? So transformation involves 4 parts, and those are translation. So when you see the word translation, you're always thinking slide. So we're talking about moving left or right, up or down. Okay, sliding or gliding, all right? It also involves reflection. So when you think reflection, it's as if you're looking in a mirror, so we always think flip, all right? Rotation, a turn. So you have an object and we're gonna turn it. So when we think rotation, we're always thinking turn. And finally, we have enlargement. And so when we talk about enlargement, we talk about something becoming bigger, or in some cases, smaller, okay? So when we talk about translation, again, we're talking about moving or sliding an image, object, or figure without changing its shape. So note well that all points of the shape move the same distance and same direction. So here we have an example of an object being translated, and our object is represented by the blue triangle there called PQR, and our image is P prime, Q prime, R prime. So we went from the blue triangle and we translated it to the pink triangle. So when we're doing translation, if we choose any point on the object, so let's just choose P. So if I choose P, I need to know what point that is. P is here, and I need to get to P prime. How do I move? I need to move left or right first, okay? So based on where it is, it's telling me to get to P prime, I move left. So let's count how many places left we have to go, and then we'll decide if we go up or down to get to P prime. So if we're here at P, we're gonna go to the left 1, 2, 3 places, and then based on the position of P prime, we know we're going upwards. So we go up 1, 2, 3, 4 places. And so this translation can also be represented as what we call a vector. So we went to the left 3 places. So the left 3 places, and we went up 1, 2, 3, 4 places. And so that could be described as a negative 3, 4 translation, okay? Just an example. In real life, we have some examples here of where we can see translation, right? So these are just some examples of translation in our everyday life. Next, we're talking about reflection. Reflection is the flipping of an object, image, figure across a line, which we refer to as the mirror line, without changing its shape or size. And so here we have two triangles on a graph, the blue triangle on the right, the yellow triangle on the left. So we can say that the blue triangle is a reflection of the yellow triangle or vice versa. Either way, it would be a reflection over the y-axis, and we know that our y-axis would be our mirror line because that is the middle between both those objects, all right? So here, that's something we're used to. We look in the mirror every day, right? So just some other everyday examples of reflection. Rotation. This is turning an image, object, figure about a fixed point. A rotation may be clockwise or anti-clockwise, all right? So here we have a series of triangles. Always note your axes. It's important to label those. So again, based on the name of the triangle, we know that the purple triangle is our object and that everything else is an image or a rotation of that original object, okay? So we know clockwise based on the movement of a clock, right? So when we say clockwise, we're talking about moving in this direction, going around the graph, okay? So it can be said that the yellow triangle is a 90-degree rotation clockwise of the original object. And if we continue going around, so this would be 180, right? 180 degrees. And the blue one would be 270 degrees. Okay? So that's if we were doing a clockwise rotation. So if we were doing an anti-clockwise rotation, let's use blue, we would be going in this direction. And so in this case, since the purple triangle is our object, the blue triangle would now become our 90 degrees rotation anti-clockwise. The green one is still 180 degrees. And now the yellow in this case would be our 270 degrees. And that's if we're moving anti-clockwise, okay? All right. So another example, people like to play with this. This is what we call a Rubik's Cube, and this is just an example of rotation, okay? You know the object of playing with something like that. And this is another example. This is something that we here in Antigua and Barbuda may see, depending on where we live or maybe where we're going to, right? And finally, we're on enlargement. So enlargement is expanding an image or object or figure without changing its shape. And remember, when we say enlargement, even though it says expanding, we also think of making something smaller as well. So it would just depend on the scale of enlargement. So here we have an object and the enlarged object. And when we talk about enlargement, we always have to have a point of enlargement, okay? And so from this diagram here, we can tell that the point of enlargement is our origin, which is 0, 0, okay? So How we would know in terms of the scale factor, there's more than one way to do it. So we can count from the point of enlargement to any point, and then count again, either from the point of enlargement or the point you counted to the enlarged object, okay? So if I'm here at the origin, 0, 0, I'm choosing a point R. I went to the right one and up one, okay? So how do I get from the origin to R prime? I would go to the right 1, 2, 3, and up 1, 2, 3. Now, if I do a division or a comparison of from origin to the point, I would realize that the green triangle would be an enlargement of a scale factor of 3, okay? So another way, as I mentioned before, would be if we just chose a side, counted how wide it is or how long it is, and did a division or comparison to the similar side, we would also be able to come up with the scale factor. So if we count from R to Q, let's just use that side. R to Q, I count 2. So 1, 2. And if I count R prime to Q prime, I'll count 1, 2, 3, 4, 5, 6. So I'm counting 6 on the enlarged object and 2 on the original object. And so if I divide 2 into 6, I'm going to get 3. So you see, there's more than one way to come up with the same answer. I guess it just depends on your preference or which one comes easiest to you, okay? So this is an enlargement by a scale factor of 3. And then these are just some examples of enlargements in our everyday life, okay? So the picture in the bottom, that could be either picture frames or even TVs. You know that TVs come in different sizes. They may be showing the same thing. Or in terms of the size of the picture frame, you want to choose the appropriate size based on the size of the picture that you have, or vice versa, all right? All right, so now we're going to talk about the coordinate plane. We mentioned briefly parts about it, but now let's really get into it and talk about it in isolation. So here you have what we call the coordinate plane. Now remember, when you see your coordinate plane or you have to draw a coordinate plane, you always have to label your axes. So this one is color-coded for you, but of course, you know, when you're labeling your axes, you always name them at the end of the arrow. So our red line here is our y-axis. So usually we just put a y on the top, and the green line is our x-axis, okay? So in addition to labeling the axes, and I just want to talk about what we have, what each of these sections are called. So you'll notice we have 4 sections. These 4 sections are actually called quadrants, okay? So this is the first one here is what we would call quadrant 1. And this is where our x values are positive and our y values are also positive, okay? So we're talking about x comma y. Now, when we name our quadrants, we actually name them in an anti-clockwise direction. So if this one is quadrant 1, then over here would be quadrant 2. And we'll notice that our x values are all negative over here, and our y values are all positive. All right, so remember that's x comma y. Then we have quadrant 3 down here. And over here, our x and our y's are both negative values. And our final quadrant, quadrant 4, our x values are positive again. However, our y values are negative, okay? So now we're gonna go into plotting points. Just have one example here. The point is already given to us here at the x, the black x, and this point is named 8, 5. How do we know that it is 8, 5? Remember, when we are plotting points, we always start with our x values. And so the 8 here is our x value, and the 5 is our y value, which means we start from the point of origin, and because the 8 is positive, we move to the right 8 times. So that's what happened. We started at 0, 0, and we moved to the right 8 times, and then it says go up 5 because the 5 is positive. And so when we go up 5, this now becomes our point 8, 5, or coordinate 8, 5. Okay? Here we have another point, and it's actually named there -2, 4. So how did we get there? Remember, you start from the point of origin, which is 0, 0. And because it is -2, that means we move to the left 2 times, which is what happened, and then went up 4 times, right? So by now, hopefully you would have realized that if we're talking about to the right or up, our values are going to be positive, or if we're talking about left or down, we're talking about negative values. Okay, so for this next graph, we're actually going to take time and label these coordinates. So we need to find out what position these different shapes are in. Okay, so let's start with the first point here, the triangle. And so how do we start? Again, from the origin, we're going to the right 1, 2, 3 places, and we're going up 1, 2, 3, 4 places. And so this would be point 3, 4. Okay? Moving downwards. From point of origin, remember you always go right or left first, the x value comes first. So we only went to the right once, but then we went down 5 times, and so this would be 1, -5. Over here at the pentagon, so from 0, 0, we go to the left 5 times and down 2 times. So we go to the left 5 times and down 2 times. And the last shape, our square, from 0, 0, we went to the left 3 times, but then we went up 2 times. Okay? That's all there is to plotting points. Okay? It doesn't get any more difficult than that. It's actually quite simple. Okay? So here, this brings us into our first question, our first practice question. And this says, which transformation maps shape S onto shape P? Which transformation maps shape S onto shape P? So notice here, this is actually a giveaway. It actually said mirror line. So which of our transformations talk about a mirror line? A reflection. So we know that P is a reflection of S. Just by process of elimination and the diagram that was given, it already told us it was a mirror line. We knew it wasn't an enlargement because the figure didn't get bigger. We knew it wasn't a rotation because there was no point of rotation. It didn't actually turn and go anywhere. We knew it wasn't a translation because it didn't slide or glide. Because if it translated, it would have been in the same position. But notice it flipped. Okay? So that is a reflection. Question 2. What type of transformation maps triangle ABC onto triangle A prime, B prime, C prime? Is it an enlargement? Is it a reflection? Is it a translation? Or is it a rotation? Okay? So notice that the triangle started, both of them, the A and A prime happens to be at 0, 0, which is the origin. Now, which one of those 4 best describes what's happening in this picture? We already can take out an enlargement because we know that the shape is about the same size, so it didn't get bigger, it didn't get smaller. And we can also rule out a reflection because based on the position of the two triangles, where would have been the mirror line? It's not a reflection. Translation again, remember the object itself would be shaped the same way without changing any position in terms of how it looks, but it changes position as to its location on the graph. So it's also not a translation. So this is in fact a rotation. And if we had to be specific, we would be able to say what degree of rotation this is. And based on where, if we take a look, not at A because A didn't move, but if we look at B or C, if we look at B and B prime, we'll notice that it creates an angle here. Hopefully you'll be able to, you can see the angle that's happening here. In any case, it's a right angle that's being created, and so we can fairly say, if the question asked us, that this was a 90-degree rotation, and it would have been an anti-clockwise rotation because the object is in quadrant 4. Okay, so if we looked at B to B prime, following, it's going this way, and it comes up this way, that's a 90-degree, right? Or if it was, if we looked at C prime and C, it goes up this way. Notice it is a right angle as well, right? So we know that this is a rotation, and specifically a 90-degree rotation. Question 3. In the diagram below, the translation by which A, B, and C is mapped onto A prime, B prime, C prime is represented by, and notice all of the options there are all vectors. So they want to know from the object, which is ABC, how do we get to A prime, B prime, C prime? All right, so if we're at, just choose any point on the triangle. Let's just choose A. All right, so if we're at A, how do I get to A prime? Did I move left or did I move right? I moved right, and I now need to count the places right that I went to. So I went 1, 2, 3, 4, 5, 6 places right, and then I had to go downwards. And so I know that my top value is going to be positive, and my bottom value is going to be negative, so already we can eliminate and come up with our answer. But I went down 1, 2, 3, 4 places. So our answer is C, 6, -4. Question 4, the image of a point P, which is -3, 2, on a translation 5, 2 is which of the following answers? So they gave us the coordinate of a point P, and they want to know when I translate this point P on the translation 5, 2, where is the point now located on the graph? So one way to do this particular thing is to actually change our coordinate into a vector. And then just add it to the translation vector. And so our coordinate is -3, 2. So if we change that to a vector and we add it to 5, 2, okay. If we add -3 plus 5 and 2 plus 2, so -3 plus 5 is equal to 2, and 2 plus 2 is 4, all right? And then, of course, we'll now change this back to a coordinate, which is 2, 4. So you'll see our answer there, which is 2, 4A, but we're also going to do it on a graph. So our point P is at -3, 2. So remember, -3, 2. So our point is going to be here, -3, 2. This is our point P. right? And so it says translate it under the translation 5, 2. So which means I'm going to the right 5 places and up 2 places. So if I move to the right 5 places, 1, 2, 3, 4, 5, and I go up 2 places, 1, 2, this is now P prime. And we can see that it is here at 2, 4. So you see, either way, we end up with the same answer. So again, this is a case where you could use whichever method is your preference. All right. Question 5. Which of the following best describes the transformation of the triangle ABC onto A prime, B prime, C prime? Is it a reflection in the line y equals x? Is it a reflection in the line y equals negative x? Is it a rotation of 180 degrees about the origin? Or is it a reflection in the y-axis? So let's talk about those lines that they mentioned, because maybe you haven't heard about them. So let's talk about those lines. So where's this line y equals x? This just means that the values of our x are the same as the values of our y. And so that means this line would be going this way, right? So this would be our line y equals x, right? Our line, so is it a reflection in that line? No, so we can eliminate A. Is a reflection in the line y equals negative x? Now, this just simply means that our y values are positive and our x values are negative, and we'll know that that happens here. And so this would be our line y equals negative x. Is it a reflection in that line? If it were a reflection, what would the shape look like? I'm going to go ahead and say no, it is not a reflection, because remember, if it were a reflection, that it would have flipped. And so the position would be a little bit different than what we see here for A prime, B prime, C prime. So let's go ahead and actually flip that in our line y equals negative x and see what that would look like. So this is our line y equals negative x. If this were a reflection, what would it look like? Our A indeed would be in the same position, but where would B be located? So B prime, if we were to flip it, or in the case if you had paper and you folded it over, what would that reflection look like? So based on where B is, this is telling me that it would actually be here. And so without even plotting C prime, we already know that it's not a reflection in that line. Right? So is it a rotation of 180 degrees? So if I connect my A and A prime, my C and C prime, and my B and B prime, we'll notice that they all lap in over our origin, which is 0, 0, which is actually where they told us that one was mapped onto the other, okay? So we also notice if we were to measure from C to C prime, that we get a straight line, and we also know that a straight line is 180 degrees. And so our answer here would be C, okay? This wouldn't have been a reflection in the y-axis, because based on where the object is, if it were a reflection, it would end up being in quadrant 2. Question 6. Which of the following shows a reflection in the line y equals 0? Now you'll notice that I actually didn't reveal the options, and that's because we need to know where that line equals 0 is, what it looks like. Okay, so let's just start with a blank coordinate plane, and we're going to talk about y equals 0. So all this means is that there's some point on this graph where every time you choose a point on this line, the y values are always 0. Okay, so let's start with where we know for a fact it's 0. Where is y 0? right here at the origin. Right? So here at the origin, y is 0 and x is 0. So let's just choose another point on either our y-axis or our x-axis and see what's happening there. So let's just choose this point here. That point there, our x is 3, but our y is 0. Okay? So I'm going to go ahead and say that this line here, our x-axis, is actually our line y equals 0. Is that enough proof for you? Maybe not. Let's choose another point. Let's just choose one on the other side of the axis. So if I choose, say, this point here, -4 on the x-axis, my x value is -4, but my y value is still 0. Okay? So what this tells me is that my x-axis is that line, y equals 0. And that also tells me that if I went ahead and I looked at my y-axis, I could safely say that this is where all of my x values would also equal 0. So our y-axis is known as the line x equals 0, and our x-axis is known as the line y equals 0. Right? So let's look at the options that we have here now. So we have A, B, C, and D. Knowing that line y equals 0, which of these 4 options is a reflection in that line? We already can go ahead and eliminate a few of them. Okay, so I would have eliminated A and C. So now I look at B and D. Which of those 2 would be a reflection in the line y equals 0? Remember, when you do a reflection, the object flips. Okay, so by examining these 2 options, the correct answer would be B. Okay? Question 7. The point P, which is at 2, -4, undergoes a rotation of 90 degrees in a clockwise direction about the point 0, 0. What are the coordinates of the image P prime? Okay, so this is similar to one that we did before. So here you have a point P, which is at 2, -4, and they want it to be rotated 90 degrees about the origin, which is 0, 0. They want to know what are the coordinates of the image P prime. Now, I can give you rules, but sometimes it's better to see it in action. Okay, so we're actually going to just plot our point P and rotate it 90 degrees about the origin. Right? So point P is at 2, -4, 2, -4. That means my point P is down here. Right? That's my point P. And the place of rotation, or the origin of rotation, is at 0, 0, which is here. So imagine like P was attached to some string, and I need to take it 90 degrees. So let me use a different color for a string. We're just going to imagine that, right? So if I had, oops, that doesn't look good. All right. All right, so P is attached to some string, and I'm going to rotate it 90 degrees. And remember the direction we're going. It says that it needs it 90 degrees clockwise. And so if we're going clockwise, we know that we're going in the movements of a clock, right? The hands of a clock. So if we're now in quadrant 4, that means it's going to take me over here into quadrant 3, right? So let's imagine that this string is moving. So if I were to move it, we know that 90 degrees creates a right angle. So if I were, assuming this is nice and straight, I create a 90 degrees. So I'm swinging this thing 90 degrees. I've created a 90-degree angle here. That means my point P prime is going to land right on that line there, all right? Going back to red. And so I know that it's going to end up here, because of the distance that it is from the origin as well, okay? So is this the only way to do it? No, it's not. It's never the only way. A lot of times, it's just how you think about the question. So how would I have come up with the answer? And where's this point? This point is -4, -2, so we already see that it's revealed there in option A. But how would I think about this? I have here my x value and my y value, right? So if I'm going to be rotating it 90 degrees, and I already know that based on where it is, both my values are going to be negative. If you look at the options clearly, only one of those actually have 2 negative values, okay? But another way you could have done it, if you swapped the x and y values, and so y became x, and x became y, and change the value or the sign of the other thing, and we got that right there. Okay, so our answer there is A. Question 8, we're almost done. In an enlargement, triangle ABC is mapped onto triangle A prime, B prime, C prime. The center of enlargement is the point 1, 0. What is the scale factor of this enlargement? So just remember what we talked about in the beginning when we looked at enlargement and the example that we had there. So we always need a point of enlargement. And they told us that our point of enlargement here is 1, 0. So that means our point of enlargement is there, 1, 0. So how do I get from 1, 0 to any point on the first triangle? And then how do I get from 1, 0 to some other point? Or I choose a side and divide by 2. And so that's what I'm going to do. So I'm going to choose the side AB, and I'm also going to choose this side. So because I choose AB, I have to choose A prime, B prime. Okay? So how long is AB? AB is 1, 2. And A prime, B prime is 1, 2, 3, 4, 5, 6. And so if I divide 2 into 6, I get 3. Or maybe you don't believe me, let's choose another side. Let's choose BC and B prime, C prime, because it doesn't always have to be the same side, okay? So here, from B to C, I went up 2. And from B prime to C prime, I went up 1, 2, 3, 4, 5, 6. Notice that it's still 6 and 2. So if I divide 2 into 6, I get 3. And so your answer there is B. All right. So this is an enlargement by a scale factor of 3. Question 9. The diagram below shows a point. What are the coordinates of its image after reflection in the y-axis? So remember, when you're doing reflection, you always need a mirror line, and they actually told us what that mirror line is, and that it is the y-axis. So they gave you the point, that big old red circle there, and they want to know if I reflected this over the y-axis, what would it look like? So if you imagine this as a sheet of paper, y-axis is the middle line, the mirror line, or the middle. So if I fold this paper in half, where's that dot going to end up on the other side? So how far away is it from the mirror line? So if I count, So if I count from the mirror line, I count that I went to the left 1, 2, 3 places. And so I do the same thing going in the opposite direction. So I would count 1, 2, 3 places. And so this would be my the location of my new object. And this is at point 3, 2, which is A. Okay. Question 10. Which of the following best describes the transformation of the triangles to the right? So which of the following best describes the transformation of the triangles to the right? So we have a green triangle and we have a blue triangle. And if we look at all our options there, we notice that they're all reflections. So we don't even have to worry about rotation, enlargement, all these other things. We know it's a reflection. And what did I say is important when you're doing reflection? That mirror line. So you have to find the middle of where these points are being reflected, or over which the points are being reflected. All right? So whichever one happens to be the object and whichever one is the image, that wasn't clear, but it's unimportant. We just need to find the middle. So when we look, the middle actually happens to be this line here. So we now need to decide which line is this. Is it the x-axis? No, it's not. Is it the y-axis? No, it's not. Is it a reflection in the line x equals -2? Well, we don't know yet. Let's check that out. How do we know if this is the line x equals -2? That would mean that all of the values, whenever we choose a point on the line, our x value is always -2. Is that true? No. So it is a reflection in the line y equals -2. And we already know that because if the x-axis is the line y equals 0, then we can safely say that this is the line y equals -2. And so our answer here is D. Okay? All right, so since there isn't another episode to follow up with practice questions, here's a piece of artwork by M. Escher, where you can apply your knowledge of transformations. Take a look at the piece and see which transformations you can apply. It has been a great pleasure being your CSEC Mathematics Homeschool 101 teacher, and I hope that you've been able to find these sessions useful in your mathematics journey. Please remember to utilize the multiple choice test-taking tips and strategies when taking your exams. Hopefully, all viewers were able to gain a more positive outlook on mathematics and have become more comfortable and confident when faced with mathematical problems. So keep practicing and good luck.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.